should be a very quick one. Mind you, it's had a coat of paint. This is a Rotel 240, which is supposed to have never had a screwdriver to it. March 2024, Rotel RVC240, and it's 11101-400. Right, and it's come with a power lead, so we won't use that, but we will use, I've got a bit of a stub power lead usually on here, and we'll plug that into PA. Connect it to power. And it has come with the correct original Rotel coffin mark. That's not just a decal, that's the real thing. But we won't do it with that. We'll run it with that at the end. We'll use the standard Cybernet mic. So high, normal, off, normal, CB, minimum, maximum, maximum, and see whether it works in PA. Testing 1 2, testing 1 2. So mic gain on these 1 2 1 2. Yeah. So that sounds how we'd expect. Switch picture in picture on. So we can tick off that and the meter lamp and the speaker. Right, transmit. So on the 3-watt scale, I need to connect it to the test instrument. So, never had a screwdriver to it. Doing 3.6 watts. Channel 40, 3.5 watts. Channel 1. 3.6 watts, that's exactly how you'd expect it to be. We've set for 3.8 at the factory. And low power, well, that's not normal. That's 900 milliwatts. Current consumption, full power, 1.06 amps. Deviation, we'll have a quick check on here. I'll have to retune this because we were doing CPT yesterday. Wallow, it says it's 4.2. We're going to take that with a pinch of salt because the machine may not be playing ball. We'll need to do the VCO on this, and let's look at the frequency. The test set's been on more than an hour. The frequency counter 2779097. Which is what you'd expect after 40 years. It's not off frequency, it just needs a little bring up. Let's set the signal generator to the same as that. 27 791 79097 2779 test. There we go. Right, we'll go to the SINAD meter and plug in the test equipment speaker just like that. I'll tell you what, this is really hot receive. It's 0.2. I'm going to have to change scales because we've gone off that scale, but the trouble is there's a bit of overlap. So it's 0.2 there as well. And for 20 dB it's 0.5. Squelch to full. Oh. Never opens. The threshold. Is 0.68. On transmit, the meter says 4, and on receive for 100 microvolt signal it doesn't say 9. It says 9 at 1 millivolt, so that's a bit mean. Right, we will open it up and make a start. Try and get this done. It's currently about 1:30. Try and get this done in half an hour, and then we can do an on-the-air test. If we do one in the day, it needs to be done before 3. Otherwise, it needs to be 7:30. It's got some surface corrosion. Well, it doesn't smell of fags, which is nice. I can't see any silliness. I can't see any filters. I can't see it needs any capacitors changing. I could do with just pushing that out a bit. Just like that. And we want the multimeter. and channel 40 selecting. Resistor 4 is the test point between there and earth, not chassis. Earth point is there. Resistor 4 is there and it's never been prodded. Should be 4 volts on receive. And on transmit it should be 4 volts. It's 4.78. So now it's far enough out for me to need to adjust it. I'll do the receive one first. I'll do me. So it's now, I should have done 4.78, and that should have been that's now 4.11 stroke whatever we have in transmit. I'll let that go because it's affected it and brought it down. Check on channel 1 and it's 2.33, which is fine, and 2.22, which is fine. So little tiny twiddle. But you're doing this so that you don't have channels dropping out in temperature extremes. This and the Cybernet chassis used in the Amstrad sets, and the Uniden sets to some extent too, can often do with the VCO being twiddled. Not so with other sets. Right, transmit. So 3.6 watts instead of the 3.8 it's supposed to be is neither here nor there. I'm just going to put some service or switch cleaner on that, and that can be soaking in whilst that's the low power. So here we go. Oh, we do it on channel 20, not channel 1. So that's now centralised very slightly out. That's now exactly where it was, which is spot on. Little tiny twiddle there. Now with the the blue tool, we need to put maximum on all these three temporarily. This is going to tune up well because that's currently 4.6. That's spot on the 5. So now then we're turning the yellow one clockwise to 4.4 watts and the green one anti-clockwise. They say for 3.8 watts, but in fact of course we're allowed 4. There we have it. So I now have 4 watts. With any luck it'll even draw less current, but we'll find out. Channel 40, 4 watts. Channel 1, 4 watts. That's channel 20. Current consumption is now 1.153. 1.153, it has gone up a little bit. And then now onto the meter. So remember, these are a relative power meter, so you're setting it into a dummy load, but when we put it on an aerial, it could well be very different. It may read 1, it might bang across, but the radio is still doing 4 watts. It's relative to SWR and things. Good. Let's do low power. When I find it. So the problem with this, it was doing too much. It was doing 900 milliwatts. Oh, we're going to play that game. And it's now doing 650 milliwatts. I wouldn't say they move on their own, but there you go. Why would anyone want to turn up low power? For those of you who don't know, under CB2781 you had to reduce your transmitter power by 10 decibels if your base station area was more than 7 meters over ground level. That's what that was for. But it is a useful feature, especially if you're mobile in a car and you want to talk to the mate in the next car rather than blowing each other's windows out on 4 watts. So that is that. We're going to do the deviation now, and I'm going to use the test set behind me because this one doesn't always read right on deviation. Capacitor issues, and I've got 4.7, and I certainly hope it isn't. Right, here goes. Oh, good grief, here we go again. Wallow. Well, it's 3. So that is not a... It didn't come out of the factory doing that, because it came out of the factory doing about 1.6. So much for the no screwdriver. So I want that in the central position. Wallow. Now that's correct. So we'll plug back into the Marconi test set and see what it says now for deviation. Wallow. It says 3.5, so it's lying today. So it was 3. Now it's 2.2 to a 2.5 peak. So you're not louder, remember, you're not louder, you're wider. It's the deviation from that central point, how wide it is. So you get to a point, when it's correct, which is going to be between this 2.2 to 2.5, obviously you sound as loud as you're going to sound. Because if you go any wider, the filtering in a decent radio will chop the edges off. So then you start breaking up on the peaks. So it doesn't make you louder. Now, the rider to that is, if you're listening on with a radio that's got really poor receive filtering, like a Fidelity 1000, then you'll sound louder and louder and louder the more kilohertz you're doing. And then you get somebody on something with really decent filtering, and it will be chopped up and sound absolutely dreadful. So that's how it is. Let's do the frequency before we move away from transmit. and the frequency we will adjust. No, we're going down now. We'll go up the other way. Well, it's ended up at 27.79125. I was going to have it at not 196, but it's so difficult to get them spot on that that'll do nicely. Thank you very much. So we'll now dial that into the signal generator. Put the speaker back in, which is connected to the test instruments. Put an S9 equivalent signal of 100 microvolts on the test set. And look at the oscilloscope and see whether the detector is anywhere near where it should be. A little bit of adjustment there, and that may well have knocked the sensitivity for 6. So when I do this tune-up, it'll probably end up worse, but at least it won't be garbled. That's just a fair wear and tear adjustment. Right, we'll go to about 4 dB. Put the SINAD meter up on the thing. Currently building the Noximan SINADer kit. Mr. Chippy's putting that together. We're just putting it in a steel case. We've done the board. That'll be a video. Interesting to see that, and I'm really pleased that I think he says he's sold 230 kits of those. Brilliant. No difference. No difference. No difference. Bigger signal. IFs. No difference. Tiny difference. Tiny difference. So as predicted, it's now 0.21 microvolts, and that's because the detector was out. And for 10 dB, it's less than 0.2, but if I go to the next scale, because of overlap, it's still 2. It's still 2. So that's it is 0.2. And our 20 dB is now 0.48 because the detector's better. So that one improves, that one gets worse. Right, let's deal with this. Oh, I'll tell you what, before we deal with the squelch, we'll put S9 on the signal generator, and let's just put this to the attenuator and get this meter to say S9. And it now does. Good. Squelch. So I'll put full squelch on the radio. And now we're going to adjust that preset, the squelch preset, until the squelch opens. So it's now opening to 100 microvolts, which is where I want it. There's no hard and fast rule on that, but that's where I want it to be. That's from a lot of experience. So set the threshold on the radio, signal generator back on, see what the sensitivity is now. 0.6. I could be more truthful and put 0.605. It's not 0.61. So that's working great. Just test his mic on PA. I'll just plug the PA speaker back in. And remember, this works on the mic gain. Switch to PA.
Testing 1 2, testing 1 2.
So that's the standard replacement mic. Just make sure his mic works.
Testing 1 2, testing 1 2.
And so does the original. So we'll run the tests on the on-the-air test with the standard replacement, and then at the end we'll go through to our base station with both. So not a lot. Had the deviation twiddled. I think it had low power fiddled with, but I don't know why. But everything, it's not messed with, is it? It's just had the deviation. But the deviation was beyond where it should be, and therefore you've got it breaking up on transmit to something which is really decent on receive. Those grandstand base stations were good on receive, and anybody who was the slightest bit off frequency or over deviating would sound absolute garbage. So somebody's nicely put yellow, and you know what? I'm going to check these because I think that's the wrong way round. I would expect green to be the negative. And I would expect the yellow not to be the negative. It's not. So they are the correct way around. Right, we'll disconnect from the test equipment. And we'll plug it into the roof aerial. And see if anybody can be heard at 2 o'clock on a Wednesday afternoon here in the middle of nowhere. Well, it still plays the F word back all right. 19. Oh, better go onto high power. 19, Roger. Roger. Anyway, that works beautifully. Nice example. We'll do an on-the-air test. Thanks for watching Rotel RVC240 using the Cybernet 134 chassis from 1981.